So as Jess said, I'm Louise Duff. I'm the Catchment Coordinator with Mid Coast Council and very involved with the Manning Catchment at the moment. We're preparing a catchment management program for the Manning, including the whole catchment. So yeah, very happy to be able to have the chance to come and talk with you today. So what I'm going to cover in this talk is it's about waterway resilience, and I'm going to be talking about the features of a healthy waterway and a healthy catchment, what can go wrong in our catchments, the whole sequence of drought, fire, flood that we've just been through, a bit about climate change impacts on water, and we've recently released our water quality report card. So I'm not sure if you're aware, Mid Coast Council every year does a water quality report card. It's extended into the Manning. Was originally started in Great Lakes. So I'll give you some of the results of that for the Manning Estuary as well. And then just a little overview about land management for resilience. You've got a lot of other speakers coming after me on that topic, so I just wanted to kind of introduce that briefly. Thanks, Jess. So the big question we need to ask ourselves, and I guess the reason you're here is, do we want this for our waterways and our catchment? Beautiful streams where we can swim, beautiful riparian vegetation that's filtering the nutrients before they hit our rivers, a place where we can fish and go canoeing, a place with water for our stock and drinking water for ourselves, which of course comes from the Manning. So this is I think what we would all agree that we want for our catchment. And the next slide shows us, an unhealthy catchment, and if we don't manage our land well, this is what we'll end up with. So all of these photos were taken here in the Manning catchment, most of them in August last year and some of them later. So we can see compact soils with no vegetation, with fast runoff. We've got cattle in the river. We've got at the top left an acid plume that happened after the February rain, fish kills after the January rains. You can see algae and nutrients in the water there, weeds. So, this is the picture of a catchment that's unhealthy, and it's really up to us in the way we manage our land, whether we get that first set of pictures with the beautiful healthy catchment or whether we get this sort of a picture. So I'm hoping everyone knows this word catchment, but basically another term for it is the river basin. So it's all of the land that sheds into a particular waterway. That might be the Dingo Creek subcatchment or the Manning catchment as a whole. So all the area that drains into a particular waterway is called a catchment. And this slide shows us some of the features of a healthy catchment. So we've got some native vegetation there, and it's part of what they call the small water cycle. So that vegetation's drawing water up from the land and transpiring it into the atmosphere and actually creating rain. And equally, when that rain falls, the canopy of that vegetation is catching that rain and letting it gradually come down into the forest floor and infiltrate back into the soil. We can see a wetland along the watercourse there, which is catching any sort of eroding soil and any nutrients and keeping those low in the waterway. And we've got as well there pasture, and a good healthy pasture will also play that same role of catching the rain, letting it infiltrate slowly into the soil and stopping that really fast flashy runoff, which is when we lose all of our sediment and nutrients. So let's look at the next slide. So just going a bit more into detail about what we're looking for from a healthy waterway. So in a healthy waterway, the sunlight goes into the water column and it drives photosynthesis. That photosynthesis is producing energy through the plants, and we get a nice healthy range of plants and good plant structure in that waterway. The plants will settle sediment out, and they'll take up nutrients and they'll produce oxygen. And that oxygen, of course, is for the fish and the turtles. We're going to have a lot of water bugs, which are also part of that food chain. And you can see here on the left, there are guidelines set for things like dissolved oxygen, turbidity, which is a measure of the amount of sediment that's gone into the water. nitrogen and phosphorus, which are the nutrients. So these are the standards set in Australia and New Zealand of what we're looking for. Now, what goes wrong in a waterway, this is a way of sort of thinking about it. It just gives a bit of structure to the way you might think about what's happening in a catchment, what's happening on your property. So we undertake activities, and I'll run through some of those activities shortly, but they can be activities on rural land, and they can be activities in town like development and construction. And those activities can produce stresses. So stresses are things like nutrients, it might be acid, leachate and sediment that comes into the waterway, and then it will have ecological impacts. So you can see the way we manage those activities is crucial to manage the stresses and minimise those ecological impacts. So the next slide. So in a catchment, some of the activities that we have happening in the Manning catchment are things like land clearing, drainage of the floodplain and exposure of acid sulphate soil. We have stock like dairy, beef and horses, poultry farming, horticulture and turf farming. We have irrigation, which then washes, causes more runoff into the catchment. We have things like dirt tracks and creek crossings and earthworks like dam construction or driveway construction. And we have urban development and stormwater. So all of these activities are impacting on our catchment. Now, of course, we're human beings and these are contributing to our economy as well. These activities are feeding our families. They're part of our culture and our society. So we need to have these activities, and we need to be able to balance, I guess, that management between the economic activities that we need to survive and looking after the way we do those so that we're protecting our ecosystem as well, which is, again, really fundamental to our lives and our livelihood, to have clean water, clean air and so on, healthy soils. So I've shown you that slide with the activity, the stressor and the impacts. Now we're going to look at some of those stresses and impacts. So the two really key ones, if you're a rural landholder, are nutrients and sediment. So nutrients, you can see the cow and the tractor there. Nutrients come from fertilisers and from manures produced by cattle, and typically they include nitrogen and phosphorus. We might have on a farm a loss of the riparian vegetation. That means the vegetation along the river bank, and that vegetation is really key because it does help filter out the nutrient and sediment before it reaches the waterway. Wetlands have a similar function, and that might be a natural wetland, or it could be, a constructed wetland, like say on the spillway of a dam. So when it rains, the rain will wash these nutrients into the river, and the nutrients are they're fertilisers, so they stimulate algae growth, just as they stimulate plant growth in your garden. When the algae can do things like smother seagrass, for example, or the ribbon grass that's in the fresh water. But it also, if you have a big bloom of algae, you have a die-off. And that's where the real problem is, because when you have a big bloom of algae and then a big die-off, you get bacteria decomposing that algae. And if you run compost and you're big on compost, you might know that decomposition process takes oxygen. So as the bacteria decompose the algae, they suck the oxygen out of the water, and we then get low dissolved oxygen, and we can get fish kills, which we did see here in the Manning, not too badly luckily, but after the January rain. Another major stressor is sediment. So sediment comes from any kind of soil disturbance. So tractor work, cattle, again on the bank of the river, will be pugging the soil, eroding the bank, or it can come from vegetation clearing and loss of that vegetation cover, or from, as I said, pasture plays a really crucial role, having healthy pasture. So if we don't have healthy pasture and we have compact soils, we're going to get more sediment. Again, if we have a loss of that riverbank vegetation, that's going to allow the sediment from erosion to just flow into the waterway. Once we have rain and that washes the sediment into our streams and rivers, we get, the sediment becomes what's called turbidity. Turbidity is just simply kind of muddy water, or that brown water that you'll see after a big rain. It's just the sediment suspended in the water column. That sediment has a few impacts. It blocks light, so it reduces the amount of sunlight going in to the bottom of the stream or river where it helps the plants to grow. It smothers habitat. So at the bottom of a stream or a watercourse, you'll see all those sort of cobbly type rocks and gravel, and in there is all this sort of space and niches for your water bugs and different water critters that feed the fish. So that can just get smothered, and even refuge pools can be filled up over time with the sediment. So we start to lose those deeper pools that will hold water in a drought. And sediment also mobilises nutrients. So as the sediment comes in, it brings with us particularly phosphorus and drives that sediment cycle that we saw before. So this slide just summarises those pictures. So at the top we've got a healthy catchment. We've got some nice riparian or riverbank vegetation in the top of the picture. Under the water we've got ribbonweed or seagrass if we're down in the estuary. We've got nice clear water, and that black and white thing is a turbidity meter, that circle. So that's showing us clear water with not too much sediment, and the little white sort of pictures represent algae. And these are the things we monitor with our report card. So in the top picture, we haven't got too much algae. We've got fish, and this is an estuary, so we've got the nice marine life there. In the middle, where it's moderately disturbed, you can see more algae, and the water's starting to look a bit cloudy, and we've got less of that lovely riparian vegetation and aquatic flora, which are all helping to keep that water clean. And then as we get to the bottom, we're just full of algae, we're full of sediment, we've lost that aquatic plants, and we've lost our riparian vegetation. So this is a really heavily impacted catchment. And all of this can apply to at your own property scale. So, you know, the water that's running through your property and past your property, whether it's through your dams and watercourses and gullies, or if you're on the river or the creek, this is the same. What's happening in the catchment is simply made up of all of the properties within the catchment. So that same things can be happening in your own water. And of course, this impacts on stock. You know, stock need healthy, clean water. They've been shown to prefer clean trough water to dirty river or dam water, and they will thrive if they've got clean water. So, you know, it's not just about feel-good stuff. It's about looking after the land for people and stock, as well as for, you know, all those ecosystem benefits. So we study this stuff, and it's kind of theory, you know, and you might read about it or see a presentation with those diagrams. And I just always find it really interesting when you get out in a catchment and you see this stuff really happening. And, you know, that happens at a small scale and it happens at a really big scale. So last year in August, right in the height of the drought, we did a rapid assessment. We went to 206 sites on right through the entire catchment, through the Nowandock, Barrington, Gloucester rivers, all the way down to the estuary. And we saw this everywhere. So this is really high nutrients. You can see, and all of those things that I was just talking about are happening here in these watercourses. You can see the algae blooms. You can see the algae smothering the rock cobble that would be then destroying habitat for all the little water bugs and things. And as that algae dies off, as you can see in that bottom photo, and starts to break down, you get that really low oxygen. And the next slide is again showing us the sediment. So we can see in this picture the cattle pugging the edge of the stream, the erosion that comes, and it's not just about you know, stock. On the bottom picture, we've got a dirt road, and, you know, council's been doing some work funded through local land services to try and seal more of our roads and manage the drainage coming off dirt roads as they cross watercourses. This is the year we've just had. So some people have likened it to the 4 horsemen of the apocalypse. We've had this series of the most extreme drought we've ever had in this district, the terrible wildfires, and across New South Wales we've had millions of hectares burnt. We've then had the flood in February, and just to top it all off, a pandemic. So I think we're all kind of hanging out for 2021 to click over and hoping it's going to be a better year for us. So what have we learnt from this? The drought was, of course, a terrible time, you know, for anyone on the land. When we did that rapid assessment, we had to knock on doors and ask for permission to go in through properties. We heard of people, you know, spending 30 grand on stock feed. You know, by the time they got to the point of destocking, the market had dropped so much they couldn't, you know, really recover the cost of that, and were selling their stock at a significant loss. I remember one family, and it was heartbreaking. It was a group of women graziers who were all at one house having morning tea, and the lady said, you know, the drought's been hard on everyone. It's been hard on marriages. It's been hard on the kids. You know, it's been hard on the whole family. So, you know, it was a really tough time. And then we had the fires come through, and this slide shows you the fires and also the intensity of the fires. So where it's kind of black up at Crowdy on the coast there is the highest intensity. Then you can see Kappangat and Saltwater, that entire catchment was burnt. And then you can see this area through the Manning and the sort of fires that came through here. So, you know, that's obviously had a big impact on water quality and everybody on our land in general. So these next couple of slides look at, you know, what happens when we have a fire. We've already looked at this slide of before the fire, where we've got the native vegetation and the pasture all helping water to infiltrate slowly into the soil, stopping that sort of erosion and nutrient runoff that's the problem in our waterways. After the fire, we see a loss of canopy, and so the rain's just hitting the ground. We see a loss of ground cover, and so then we're getting rapid runoff going into our watercourses. That's bringing with it the burnt material, as well as causing erosion and bringing in sediment. With the fire, interestingly, the worst fire impact for the water quality is when it's not as high intensity. When it's really high intensity, everything's just, you know, combusted into ash. And ash is basically inert, so the ash doesn't have such a high impact when it hits the water. But when it was burnt, where, you know, I came down to Dingo Creek when we had that first rain, and you saw big chunks of, you know, dead leaves, black dead leaves and sticks and all of that. And even I live at Boomerang Beach, and we had it all over the beach there, so it came right through our system. Those bigger pieces of dead organic matter are having more impact on the water, because as with the algae we talked about before, they have to break down, and as they do, they're taking oxygen out of the water. We're going to get more erosion, more runoff coming into the waterways after that fire. And then following the fire, we have recovery. So you can see the amazing regrowth we've had in most of our forest, with the canopy starting to re-establish and ground cover starting to re-establish. So again, that's going to catch the water as it goes in and help it infiltrate into the ground. But we have had some big algae blooms that have come in after the fires. And, you know, of course, we've had a lot of weeds come in as well, and weeds that maybe we haven't seen so much or that have really taken off. And then we had the flood. So these slides show you a couple of things. Interestingly, the average rainfall in the top slide, the average rainfall for the year in 2020 was higher than usual. So that's that orange bar there. And you can see, you know, the average rainfall is that horizontal blue line. So you can see, you know, it was really one of the wetter years in that sequence, which goes right back to the mid-90s. But all of the rain fell basically in February. So we had the massive drought early on, and you can see in these bottom slides, this is just a short sequence. This is when we did the report card monitoring. So that monitoring happens across 6 months, and they have 6 samples. And what you can see there is that February, you know, we had a bit of rain in January, which I think really saved us, because I believe we got a bit of nice ground cover coming up during that rain. You could see the pastures greening up a bit, and I think that helped us in February when we had that really big rain, because we already had a bit of stabilisation. Yeah.
I'm having a lot of trouble reading the detail of these slides. Is it possible to enlarge them, please? Thank you. Thank you.
Great. And the next slide. So this just shows us again that February rain. You can see a bit of rain in January, and then the really big peak of rain in February. So that spike in February brought us up over the annual average for the year, but we'd had this terrible drought preceding it. So what we then had was turbidity in January from that first rain. So these photos, I came out on the first weekend, we had a lot of rain. In Kempsey, we saw mass fish kills, thousands and thousands of fish, and I was really worried. And I came driving all out through the catchment, and you can see Dingo Creek there, how muddy or turbid it is. And there was a lot of, you know, dead matter coming down that creek. The next photo's up in the Nowen dock, and you've got, you know, the bare soil from the fire and the sediment carrying in through down into the Nowen dock river. We had some fish kills, but really not a lot. So the fish kills were in a few different locations. We had reports maybe in about 5 locations, but nothing like the fish kills we saw in the Kempsey River. And so this is from, as I said earlier, the nutrient making an algae growth, and then as the algae breaks down, taking the oxygen from the water. Don't feel like you need to read all that, but these are just some of the drought pressures that the guy who does our water monitoring noted, and things that we saw as well. So even after the rain and the fire, the drought was the primary pressure. So you could see the evidence of the drought, you know, after the rain and after the fires, and it was still the thing that was most noticeable in the catchment. We had high water temperature maximums. We had higher than usual salinity. So down in the estuary and at Farquhar, where we have the closed lagoon, we had higher salt. And the salt extended further upstream than usual. Even after that January rain, the symptoms of the drought remained evident, and we had ash in most systems, so most of that from airborne material. The risk to water quality from fire is still really poorly understood, and this year hasn't really helped because we had the fire, but we'd previously had the drought and then the rain, so they haven't really been able to tease out and isolate what was the impact of the fire and what was the impact of the flood and so on. So there is research going on, and I think a lot of that's focused on the south coast, and that will give us some information. I won't dwell on this slide. You've already heard from our previous speaker about climate change risk. But the way I see it, what we've just been through is really giving us a taste of what it's going to be like more and more under climate change. So we're going to have longer periods of drought. We're going to have more of these increased intensity rainfall events like we had in February. And with the warming climate, we'll have more fire. So we've really, in a way, with the catchment planning that we're doing, we've had a chance to really, it's really hitting us in the face, those sorts of impacts and what we need to try and manage for. So I'm nearly finished this presentation. I just wanted to give you a little bit on the results of our water quality monitoring this year. As I said, Council does it every year. So we measured two things. The first is algae or chlorophyll A. So chlorophyll, if you remember your old high school science classes, you remember that chlorophyll is the thing that does the photosynthesis in the plants. And that's how they monitor algae in the system. And they also monitor water clarity, which gives us sort of the reverse measure, if you like, of sediment and turbidity. And the other thing that I haven't spoken about that really affects how healthy our waterways are is just the way that water moves through the system. So this is called the hydrodynamics, and it varies significantly between a river estuary like the Manning or a lake estuary like, say, Wallace Lake. So in the river estuary, if we've got low rainfall, we've got pretty low flows, and the amount of algae or sediment coming through the system is quite low as well. And we'll have the same thing happening in the lake estuary. If we look at the next slide, when we've got moderate rainfall, as we had in January, what you get is increased inputs of those nutrients and sediments coming in. And because it's not just flushing through or flowing through really fast, that hangs around in the river. Now, in the Manning, we actually have quite a long, what they call residence time, which is the amount of time it takes for the water to get from the top of the estuary out to the sea. It takes 30 days, actually 31, which is really slow for a river estuary. And if you think about it, it makes sense because you've got all the islands, the channels, and that whole lagoon into Farquhar as well that the water's moving through. It's not just a river that just runs out at the heads. In the lake, we have even higher residence times. I'm not sure what it is for the Wallace, but it's going to be a lot longer because it goes all the way down to Charlotte Bay. So the moderate rainfall is almost worse, and then when we get the high rainfall, it did just flood through, and it actually pushed, in the Manning, it pushed all that algae and burnt material, sediment, it pushed it through the system and out to sea. So then we actually get an improvement in the water quality, and that's what our results showed us. Meanwhile, in the lake estuary, you know, the water's still got that very slow movement through the lake. So we're still getting high algae and sediment there. Do you want to see Wallace Lake, what happened there, or shall we skip to Manning? Manning. Okay, we'll skip that one. We did a talk at Naviac last week. So in the Manning, these are the grades. So what you can see here is this is just the estuary. So the estuary is up to the tidal limit at Abbott Falls, just above Wingham. So it's not talking about the river system itself. Now, through the catchment management program that we're developing, I'll be looking at extending this report card right up through the system. But at the moment, you can see Upper Manning and Dawson River scored a C. So that's a fair grade. It's not good. B is a good grade, but what we'd really love to see is A grades. So the upper estuary was worse and the lower estuary actually scored better. So I'm not going to go into all of this detail, but what we found is that algae is driving these results. So that algae is coming from nutrients. So during the drought, the manure was building up at the edge of the waterways. It wasn't getting washed in. And then when it came through, we had algae increasing in the system. What can I tell you there? In the Dawson River in particular, 80% of the samples exceeded the trigger level for algae. And we're really not sure, what was influencing that, because that was the case before the January rains and right through after the rains as well.
Can I just ask you, do we have that blue-green algae as well, either here or on the flag? Because if people go swimming at the rock pool in Jakarta, they could be affected, and I do that sometimes, so I would like to know.
Yeah. We haven't had outbreaks of blue-green algae, so there's lots of different types of algae, and as you say, the blue-green algae is toxic, and we have had problems with that in the past. You might remember Mile Lake, but as far as I know, we've had no reports of that yet. In the mid-Manning, the algae levels were slightly higher than last year. But when those February rains came through, as I said, they sort of flushed it through the system and kept the levels low towards the end of the sampling. And in the lower estuary, water clarity and algae levels improved slightly compared to last year, partly because we had the low rainfall, so it wasn't coming in, and then we had the big flood, so when it came in, it pushed through the system pretty quickly. Now, Farquhar Inlet, a lot of people are interested in. It retained its good grade this year. Last year it was only like 1 point below the top, A grade. So the water actually is good quality at Farquhar. The bar was opened in February ahead of that February flood, but they can't really tell what effect that had on the water quality, but obviously it made that flood water go out to sea. So just to conclude, you've got on the left here the unhealthy catchment with the nutrient and sediment problems that we've been talking about. And on the other side, you've got some of the features of a healthy catchment, which you're going to hear a lot more about from the following speakers. So what we're looking for is vegetation on our steep slopes, particularly native vegetation, but also pasture. That's going to reduce erosion and sediment runoff into the waterways. We're going to have a nice, abundant river life, the plants and animals in that habitat. We want fertiliser to be applied and stored away from waterways, so it's not just washing in. We want to keep stock out of waterways, and it's not an easy thing to solve if you're on a property where your cattle are have free access to your river. But I'm sure you're going to hear more from our other speakers about some of the methods to manage stock to try and keep that vegetation on the riverbank healthy. And productive pastures, as I've said, are a really important part of this mix because they're keeping the soil organics in the soil, they're helping stop the runoff and let the rain infiltrate in and protect the water from that sediment and erosion runoff.